Okay, how's everybody doing? Can everybody hear me?
Good
Yes.
afternoon, sir. Yes, sir.
Hello.
Fine.
Yes.
Okay, great. So so thanks for joining. I think there's still a few people joining, but it looks like we got about 20, so that's a good start. And this meeting will be recorded, so in case you get logged off or have any technical difficulties, or for those who could not, I think I have to let someone in here. Okay, so Chris, you can't hear me still? Or not? Okay, great. Yeah, I might not have started talking yet. So there is a, if you see that chat feature, let me post something here. So there's the chat feature, and if you have any questions or need to say something like during the lecture, you can post whatever to the chat, and I'll try to check it throughout the time. Or you can, I assume that most of you have your microphones muted, but if you want to ask a question, just go ahead and unmute yourself, and you can ask any question. So you can communicate. I have to have your video on because I'm going to share my screen pretty much the whole time, and we can kind of work together. But if you want to comment or have any questions, or need me to do something again, you can post it to the chat, or you can ask a question just by turning your microphone on. Okay. Then I think everyone can hear me, but let me know if you can't hear me or need me to repeat anything. But I think it should be good to go here. So if this is your this is your first time using WebEx, you probably use Zoom or something similar, but if not, it's pretty easy to use. We're going to do an online shared meeting, and I assume most of you are Zooming from home or remotely, but maybe some of you are in the classroom. We'll be back in next week. And we do have a few more. I know that there's, I think, 2 more students who added, so I think after the paperwork is processed, we have 28 last time I checked, so it should be a pretty good group. And this will be, like I said, this is just a one-time thing. I couldn't be in town this weekend because I had prior arrangements, but I'll be back in the classroom next Saturday. I'll see you all then, and then we'll resume to the classroom. But this should be fine for this week. And if you haven't done a Zoom or WebEx before, you can kind of get it's a good skill to have. And this, like I said, this video is going to be recorded. I'm recording it, and I'll post it to YouTube, and you can access it if you want to later, in case you need to see anything or kind of catch up. And if there's any students who couldn't make it, then they can watch the video at their convenience. Okay, so let's close this. Okay, so it looks like there's about 24 of us, including myself, so that's a pretty good count here. I'll kind of start. Any questions before we start doing the material and going over stuff? Or any technical problems with getting JMP working or anything like that? I know there's some students who had to work around some permission issues with their laptop. Another student had to get a different laptop or get an updated version of Mac. So you still have a little bit of time, but now's about the time when everyone should have JMP working, or at least somewhere. You don't have to do it exactly right now, but at some point you should have the ability to use JMP to do the homework. So is anyone having issues still, or kind of waiting on issues to get JMP working? Okay, well, I'll assume that it looks like most people got it installed last week, but just if you need to still install it, it's all the software downloads are here. Okay, and so this is the JMP installation documents for either Windows or Mac. And whether you're using Windows or Mac, you should be able to download those files and get JMP downloaded, and it should be free and easy to use. But I think most students got it up and running last week. But if you do have any issues, we know this coming week because now is about the time when you got to have it going so you can start doing the homework. Um, and right, I knew that there'd be some technical issues and students joining late. So nothing's officially due today, but your first assignment will be due next week, which was doing the JMP welcome kit. So on Blackboard, under JMP New User Welcome Kit, if you click on the JMP Welcome Kit, I want you for your first assignment to do this little welcome kit, and it gets you familiar with the software. And then when you finish this, you should get a little certificate, which you can turn in for your homework. And let me show you, I think there's some students who already turned it in, so I can show you an example. Okay, so you see where it says discussions on Blackboard, and then there's a topic called JMP number one. JMP assignment number one, which is the New Year's Welcome Kit. What you want to do, if you haven't done so already, click on that, and you're going to post your certificate. There you go. So looks like Farouche has done it, and that's how you would do it. And so again, make sure that I can see your name or student ID, so I know it's just not a general certificate, kind of like this one. And so when you finish that first assignment, going through the welcome kit, you'll get a certificate. You're going to provide proof that you did it, and then that'll count for your first assignment, and that's officially due next Saturday. Okay? Okay. Just 1 second. I gotta lick this menu bar in the way. There we go. Okay, so let me know if you have any questions about the first assignment, but it should be pretty self-explanatory. Then the assignment we kind of went through last week, we did about half or a little more, and the rest was to be completed. But this assignment, under week two, so we got to week two last time. So the weeks are not 100% like week two, week one. We're a little bit ahead on week one, but I know that the week we're at today has a couple parts, so I'll kind of walk you through that. But the one we got to last week, week two, okay, so this was the assignment I went over last week, and so there were 3 questions, and you had to submit for this assignment, which is not due next Saturday, but the next Saturday, like it says here, September 16th. So that's going to require the JMP reports for each question, and then also the Word document with like a summary of what you found, like we went over the results. So this one we went over last week, and that's due in 2 weeks. But if you weren't here last week, let me know if you have any questions about that. Maybe you can get some of the notes from one of your other classmates who was here when we went over that. But we did go through this assignment last week, and you still have a couple weeks to turn it in. But just a reminder that this one is also due in the coming weeks. And when you're going to submit under discussions, and then JMP assignment 2. Okay, so we've in summary, we kind of got the tech issues and the software going last week. We went through the first 2 assignments, which are due on the due dates, and then today, um, one second. All right, so if you look, there's a weeks 3 through 4 section on Blackboard. I know we're in week 2, but this is just the way it was structured from before. But this will be a 2-part section. So what I'd like to do today is go through the material for part 1, and then I'll get you started on another assignment. But this assignment's a little bit longer, so we'll go over part of it this week, and then part of it next week. Okay, so there's 2 parts to assignment number 3. One part we'll go over today, and then one part we'll go over next week. Not due for a few weeks, but we do need to start going on this assignment because it is 2 parts and a little bit longer than the previous one. That one's here. So we will over this in weeks 3 to 4 in Blackboard, and then part 1. There's some key terms, some questions. We're going to do a little looking at T tables and F tables to do some significance tests. And that's what we'll do today. So the goal today is to expand upon the single regression where we had the one x variable. And now we're going to introduce multiple regression where we have multiple x variables or independent variables that could possibly explain the dependent variable, and go through some examples there. Okay, so that's the goal for today. Any questions so far on what I want you to do from last week, or what to expect coming forward? Everyone good on what I want from you and up to this point? Okay, so why don't we? Okay, great. All right, lots of thumbs up, so I'll take that as yeah, that's a thumbs up or a nice feature. We didn't have that originally, but now that's great. Okay, so again, I'll leave the chat feature open. And if you need to post anything to chat, or if you need to ask a question, you can anytime unmute yourself and ask a question that way. So why don't we go ahead and get started? And why don't we open up under weeks 3 to 4 in Blackboard where I'm at? Why don't we open up the weeks 3 to 4 study guide and start there? The part 1. All right, so let me introduce some of the key concepts I want to learn this week. I do have some links to videos. I don't think we'll watch the videos kind of together over WebEx or kind of the Zoom platform, but I do think these videos are pretty informative. So what I'd like you to do, if you have some time, is after we go through all the concepts, just click on the web links. They're pretty quick, short YouTube videos, and I think it'll help kind of reinforce the ideas. But probably not the best use of a WebEx meeting is to watch videos together. So I think I'll kind of introduce the concept, but I'll just kind of assign you to watch the videos. It shouldn't take you too long, but I do think they're all pretty informative videos that I found that help reinforce the ideas. So do get a chance and take a look at those. Okay, so the first concept is we're going to build upon single regression and introduce multiple regression. And what that is now we have more than one possible x variable that can explain the y variable. So in some cases, we're going to have a bunch of options like x1, x2, x3, and we're going to try and test them out and see if, in fact, some of those variables or all of those variables affect the y variable. There could be some circumstances where we kind of get rid of some variables because either they don't have a significant effect or there's some kind of correlation with other variables. But the idea is that we're trying to pick the best linear model to explain some dependent variable choice. And if necessary, we're going to use more than one x variable because in reality, there's obviously more than one option to predict something. So multiple regression is expanding upon what we did last week. And instead of having, there's going to be one y variable still, one dependent variable. We'll also have multiple x variables or multiple explanatory variables in that concept. So it's a little bit similar, but it gets a little more, there's a little more evaluation going on where you got to look at some other variables, see how the model behaves overall. And something you got to be aware of is you don't want to have a lot of, you want to use similar variables in x's like that have some correlation. Like you don't want to use two things that do the exact same thing because that's going to kind of bias your results. So we'll learn different methods in which you can kind of filter those out. Okay, binary variables are categorical variables. And so this would be something where you're not looking at something quantitative, you're looking at something instead that's categorical. So something like, are you a smoker? Are you a non-smoker? Do you live in the U.S.? Do you not live in the U.S.? Do you work for the company? Do you not? So, and it could be like, what quarter is it, or what month is it, or what year is it? So things in which you put the data or the problem into categories and not quantitative. So things that say you're in this category or you're not would be an example of a binary variable. And we're going to look at some examples on how to deal with those today. But in essence, you're going to assign categories. And if you're in the category, you're going to be like your observation would be assigned a 1, like I'm in this category. And if you're not in that category, you'd be assigned a 0, in which you're not in the category. And so in practice, if you have something like smoker, non-smoker, you wouldn't have two separate variables. You'd have one or the other. So let's say you have one variable that indicates if you're a smoker, where you put a 1 in the category or in the column. And then if that's a 0, that by default means you're not a smoker. So you only need, the idea is that you only need one less variable than your entire categories, otherwise you'd risk double counting. So for the category, you got to have one or the other, but there's always going to be a case where one or more of the categories are 0, and that's the default case that wasn't specified. Okay, let me let someone in the meeting here. So welcome. I think Saif, I think your microphone's still on, so you can turn it on. Oh, there you go. So you turn it back on whenever if you want to ask a question. But I guess the best thing is to leave it off while you're not talking, but do feel free to turn it back on to ask a question. Okay, so that's binary variables, and again, we'll look at some examples so I can kind of illustrate the use of those in practice. Um, they can also be called dummy variables. Just they're kind of interchangeable. So if you see um, binary variables or categorical variables or dummy variables, those are things that are um, categorical or not quantitative, not numbers, but putting something in a category. Okay, so the F-test uh, wasn't really used in the single regression analysis or the evaluation of the model. The F-test is going to evaluate the fact that this model itself is valid. It's going to it basically that's fine. Don't worry about it. Okay, so the F ratio is going to evaluate all of the predictor variables at the same time. So let me just write a couple things on this Word document to kind of illustrate how you'd look at it, like hypothesis test style. Okay, so what I'm showing you here is just an example. Let's say that we have three X variables. Right? Let's say that we're looking at something where so it's not a perfect terminology, but I think we get the idea. Let's say that dependent variable y is a function of x variable x1, another variable x2, and another variable x3, or that's the way we set up the analysis. And we would want to evaluate if all the betas, like the beta for variable 1, beta for variable 2, and the beta for variable 3, if those have a quantifiable linear relationship with the y variable. And what the F-test does is it would do a big hypothesis test, and it would say, I'm testing the fact that all the variables have no relationship with y, and so your F-test tells you if you can't reject it, then all the variables are essentially zero. So you're testing the fact that in this case, beta 1 is 0, beta 2 is 0, and beta 3 is also 0. So you're testing the fact that none of these variables um, have a significant effect on y. Now, if you can reject the null hypothesis and confirm the F stat is big enough, it means that your model is at least sound enough to not reject all the variables. And so the F stat tells you that at least essentially at least one of the variables is significant. All right, if your F stat is low enough, that really means that this is a really bad model and that none of the variables are significant. So you're testing the fact that all betas at the same time are simultaneously zero, and that's the test going on. So it's kind of doing a big t-test that we did last time all at once. So it's a nice thing to look at because if you can confirm the F-test, that at least means that something's going right in your model. But if the F-test is not confirmed, if your F statistic is too low, then you got to really respecify the model. Okay. Uh, did everybody doing good so far? Let me know if you have any questions, but I'll keep going with some of the terms. So thanks for the confirmations and the thumbs up there. So it lets me know that everything's going well. And next key concept, and again, I went through the main ideas. We'll look at some examples, but do take a look at the videos or the links. They're right there. You can click on them and watch them at your convenience to kind of reinforce the ideas. The next thing is to look at the parameter report for multiple regression. Okay, and so that's similar to what we did last time when we looked at the coefficient for the x variable. Um, and if it was the price variable for golf clubs, or whatever the x variable was last time when we were trying to explain the y variable and what that coefficient means. This time we have to interpret all the betas, all the coefficients, the x variables, and interpret those individually because you're looking at essentially a big model, but you're analyzing each case individually. So essentially what each beta would mean if we had something like the model I specified with 3x variables, your interpretation for each coefficient would be something like this. Okay, so obviously going to depend on what the variable is, but in general, you're looking at the coefficient for the x variable estimates the effect of a 1 unit change in the x variable, like if it goes up by 1 unit, then that is the effect on the dependent y variable. But the caveat here is the phrase, you don't have to write this every time, but you have to know it's implied, is that your interpretation is holding everything else constant. And what that means is that this interpretation only applies that linear effect on the x variable on the y variable. That if anything else changes, then this is not the case. So you're you're interpreting the result in a vacuum and assuming that nothing else changes or everything else is constant. Otherwise, you open up the room for things changing. So your analysis is basically from this sample of data. If nothing else changes, this is the effect of this x variable on the y variable. Okay, so know that you're in the back of your head. You're always going to say holding everything else constant because if something else changes, that can change your result. Okay, so the t-table we did look at a bit last time. Remember we were looking at the t-stat is big enough or bigger than 2, then that would be, we do that, let me see what we do. Okay, so actually we didn't do it last time, so it's kind of the same. It's something similar to the p-value test I did do last time that we looked at. But the t-stat is another way of evaluating the individual coefficients, right? So the test is basically the test of significance is if your p-value is low enough, or if your t-value is high enough, then you can go ahead and confirm the significance of the model. So you can use the p-value like we did last time, or you can use the t-value, which I'm going to show you this time. Both things can be used in proper interpretation to tell the audience or the researcher that that variable is significant and the result you found is not a chance. So I think I put a little link to the t-table. Yeah, so under weeks 3 to 4, part 1, if you see there, there's a link that says t-table, and I can just open up that t-table. Hopefully this works. Um, okay, so this t-table tells you the cutoff for your t statistic in which it would confirm if your variable is significant or not. So if you scroll down, in general, the cutoff is the 95% significance, which means that you're 95% confident that your results are confirmed. There's only a 5% chance that you're wrong. Which is a pretty good. That's kind of the standard reporting in journals in economic analysis or just econometrics in general. And you're going to get a t-value associated or a t-statistic associated with each coefficient. And to look at it this way, as opposed to the p-value test, which is the same but a different way to do it, is you want to find that your t-stat is at least bigger than the critical t on this t-table. So the left column, you see that little df here. That essentially means that it's the number of observations in your data set minus how many variables you use. So like if you have 1,000 observations and you have two x variables, then you have 98 degrees of freedom. So once you get up to a certain level, it doesn't really matter. But let's assume we have um, let's assume that we have 100 observations and 3x variables. Actually, that one's not listed on here, but so let's say that we have 103 observations, 3x variables. So that would give us 100 degrees of freedom, which are the number of observations minus the total number of x variables. So then we're in this 100 column. And if you go over to the critical t for 95%, you can see that there it is 1.984. So a good rule of thumb is that if your t statistic, your coefficient is bigger than 2, then that's the kind of cutoff line for significance. It can be, if it's close, you can kind of look at the table, but if it's bigger than 2, assuming you have enough observations, that's a good enough rule of thumb to confirm that it would also be the case where the p-value is low enough. If the p-value is low enough, or the t-statistic is at least 2, both those things would equally confirm if the results are founded, significant. Okay, so I'm just going to write a little statement that says if your t statistic is bigger than the critical t at 2, then that would confirm significance. Okay, so the t statistic for your x variable is that's greater than or equal to, not a sad face, is greater than or equal to 2 in absolute value, then your variable coefficient is statistically significant because that would confirm that it's bigger than the critical t of around 2. So that's what you're going to look for when you find the t-stat report in the output results. Okay, so last key concept before we start doing some of this in practice is outliers and influential points and leverage points. So an outlier would be a point that, or sorry, an observation that kind of skews your results. So if you have one finding and you see that there's one kind of extreme variable that kind of really impacts the results and doesn't fit with the rest of the data points or the line, then that variable might be an outlier. And if you have enough observations, it doesn't really matter because it'll kind of wash itself out. If it's something that's really influential and doesn't really fit in the model, you can remove it and say this data point or this observation is unusual. It doesn't fit with the model, and I removed it because it's messing up the results and it's not indicative of what's happening in the analysis. So JMP has ways to test for these outliers, which we're going to do today. But if you find an outlier, you can either you can proceed by leaving it in there if it's not going to mess anything up, or if it's kind of impacting your results in a weird way, you can take those variables out. But you got to make a note if you do your report or you publish something, because the audience or the reader wants to know why you removed something. But there are formal tests which you can use to verify what you did or why you did it. So multiple regression, adding more x variables to predict a y variable. Binary variables are categorical, where you put something in one case or not. The F ratio or the F test is testing all the coefficients simultaneously if they equal 0. If they don't, then you can go ahead and reject that test. You're interpreting the x variable parameters or coefficients in the same context as we did last time, but on the condition that everything else is held constant. The t-table is another way of confirming significance of your coefficients, and that can be used in addition to and instead of the p-value. And outliers are observations that significantly skew your results, and we can look at formal tests which can indicate those. Okay, so why don't we start going through some examples? And by that I mean I'll walk you through some of the homework concepts, and when I think you have enough examples and knowledge to do the rest of it, then I'll let you do the rest of it. But how do we do? So this homework is homework number 3, part 1. So just make a note that there is another part coming next week. It's already posted, but we'll talk about it next week. And both of those are due September 23rd. So there's 2 parts. This is like there's a lot going on in this section. I made it 2 parts. So both completed assignments would be due under the homework 3 session. Okay. So just when you're doing this assignment, it requires multiple parts, and we'll do one of the parts, go over one of the parts today. Okay, so the first question is to look in Resources 2 section and the Homework 2 document in Blackboard. So let's look at Homework 2, and then in a second we're going to download the JMP file that goes with it, and then start going through this example and learn about multiple regression, evaluated outliers. And once we got that, we can repeat the analysis for some other examples. So go ahead and navigate to Homework 2 on Blackboard. It's actually Homework 3, but it's on Blackboard, it's called Homework 2. Okay, see here, I navigated to Resources, Lectures, and Assignments, and then Resources 2. Then you see there Homework 2. So you can download that fitness JMP file, and you can open that up. It should open up your JMP. And then you can refer to the PDF document for the assignment and what you're going to do with the file. So why don't you go ahead and download and open up this in JMP like this. Okay, so if you were able to open that document up, we're going to look at a sample of athletes or runners in which we're trying to predict their oxygen levels or oxygen intake based on some different characteristics. So the oxygen is a Y variable there. We're looking at age, the individual's weight, their run time for this specific race, their like run pulse, their rest pulse, and their max pulse. So these are different health statistics or health variables that you monitor for athletes. And we're trying to use these other things to predict the variable oxy and see which one of these, or if more of these, can help predict the oxy variable, which is the Y variable. So let me know if you have any issues opening up the JMP file, or if you're still having issues with JMP. But you can let me know now, or you can let me know at a later date. But yeah, at some point, if you don't have JMP up and running by now, then it's time to start trying to diagnose it. Okay, and then we're going to follow along this little exercise. Homework 2 there. Okay, so you can follow along here. I have a little printout that I'm going to refer to so I can just keep the JMP program up and do the analysis there. But you can follow along or kind of look at the PDF for an example, but we're going to go through a multiple linear regression example and then do the analysis for two other examples or data sets. One with some binary variables, which will be a good exercise to learn that. All right, so here we go. We have 31 observations, and we're trying to use one, two, three, four, five, six possible x variables to explain the y variable, which is the oxy variable. All right, and just note that name and gender are just categories. They're not going to go in the analysis because we're looking at the metrics that explain oxy. They're just placemakers for who the individual was. Okay, so if you look at your printout or your homework PDF, you can do analyze and fit model. Okay, and we're going to select oxy as the y variable. And then we're going to select everything from all the other x variables, except for the categorical ones, and put them in the x spot. So we need you can kind of select them all together. So what I did there, sorry, don't want to select oxy. That's the y variable. Age, weight, runtime, run pulse, rest pulse, and max pulse. If you select all 6 of those at the same time and add them, where it says add under construct model effects, you're setting up a model where oxy is the y variable, and we have 6 potential x variables like that. So you got that set up there. And again, if you need me to repeat anything or you're having trouble with JMP, go ahead and you can unmute yourself and ask questions or post anything to the chat. But this is the model, and we can hit the run button to do it. Okay, so we got a bunch of stuff here going on. First thing they're referring to is the actual by predicted plot, and that's telling you that the model is at least better than average. The blue line would be just there's no effect, and the red line would be that it's significantly different here than nothing going on. So it looks like at least some of these variables do explain oxy variable. If you look, you scroll down, you can see the effect summary with the associated p-value per variable. And I guess the way the JMP is set up is kind of nice because see effect summary here where my mouse is. That blue line tells you the cutoff for significance, and essentially it's telling you that runtime and run pulse have a low enough t-value to confirm significance, but the other variables don't have a high p-value or p-value is too high, conversely, and you can't confirm that those are significant based on this test. So see how the other ones are both higher p-values below the blue line. So based on this simple p-value test, only runtime and run pulse would be confirmed as significant. So you should be getting the same results and p-values I'm getting. If you get something otherwise, you can let me know, but that should be what we're getting. You can look at uh, the analysis variance report, and that will tell you the f-stat and the p-value for the f-stat, or the probability that the model is at least better than no model. So our f stat is 22, which is usually if it's bigger than 3 or something, or sometimes even 2, that would be enough. So if the f stat's 22, that means that at least one of the variables is not 0. And we did a double check above and saw that 2 were probably significant. And look at your f value is significant at the like 99% level based on the p value being less than 0.0001. Okay, and then you can see the let's see, summary of fit report over there. So there's a R square, and there's a adjusted R square, and from now on, using multiple regression, your better metric is the adjusted R squared, because that is a better accuracy measure when you're using multiple variables. The reason why is because if you use just the R squared, the R squared always goes up. You add more variables, even if they don't have any effect or aren't any important. And then the adjust R squared will, for lack of a better word, like punish you for putting in variables that don't make any sense, or you didn't know that, but if you put in variables that don't have an effect, that aren't good variables, it will decrease your adjust R squared based on non-significant or not important variables. So it's a much better analysis of fit and better explainer for the Y variable. Use the adjusted because it controls for additional X variables that are not valid or significant parts of the model. So our adjusted R square is about 0.81. So that means about 81% of the oxy variable is explained by this model, right? So that's still the same interpretation, but just the only difference is that if you're using multiple regression, you want to use the adjusted instead of the regular one. Now, you can look at, what is the next thing? You open up the triangle for the effects test. Okay, this will show you the F ratio and the P value for the coefficients. So you can also look at the parameter. I like to look at the parameter estimate report here so I can show you the T value in conjuncture or in addition to the P values. Okay, so if you look here, now we have the last time I only had the 99% option, but now see how the P values are colored? So the yellow one would be 99% significance. The red one would be 95% significance. So just someone asked last time, but if it's 99 significant, that means it's automatically past the 95% threshold, but 95% not be 99%. So ignore the intercept, but age is significant at the 95% level. Runtime is significant at the 99% level in addition to run pulse, and then max pulse is significant at the 95% level. And you can see how the t-value for all of those cases is at least 2, and for a couple of them it's close. We'll have to evaluate. So it looks like see the t-ratio for all those ones that are highlighted is at least 2 in absolute value. The ones that are not, like 1.36, this one's 0.3, those ones you're going to have to throw out because the results didn't confirm any significance, and if they're in there, they're just not doing anything because they don't have an effect, or the effect is being captured better by one of the other variables that are already in there. Okay, so we're going to be left with a model in which run pulse and runtime are for sure. Oh yeah, so may I know what the intercept means? So the intercept in theory would be where the relationship from all these things starts. So in like a single regression concept, like the golf club one, remember you were looking at like let me show you with a okay. So just to explain, if you recall from last time, we estimated the price of some golf clubs that had on demand. Okay, sorry, that I did it the other way around. Just let me reverse the axes here. Okay, so in this example, I'm just looking at, it's best to explain what the intercept is with two variables. So the intercept would be where this line, here's the line. If you draw a straight line all the way up to here, it would be where, so in this concept, it would be the quantity in which um, the line hits the y-axis. So it would be where the relationship starts. So basically, like if the price of golf clubs was 0, there'd be like so many people who would the golf clubs either way. Question? Yep.
Hey, Professor, can you hear me?
Yeah, I can.
Is there any reason why you're doing this in Excel, not in JMP?
The only reason I'm doing this is because I didn't want to open up a new file and mess
Oh,
with
okay,
all the
okay.
yeah.
Got
But
it, got
this
it.
yeah, you could also do the same thing in JMP, but I didn't want to like close that analysis and start a new one. I just wanted to show you with the simple example. But you could also do a plot in JMP
Got it. Thank
like we
you.
did last time. Yeah, no problem.
Mhm.
So to like conclude the question, if you drew this line, went and drew that line all the way to the y-axis, and that's where it hit, that's the intercept. So it's the y-intercept. So in theory, it's the number of golf clubs would be demanded at a zero price. Um, so it makes a little more sense in the two contexts for just a one variable case. And so what it tells you is that if all the betas were zero, uh, this is what the oxygen level would be, I guess. So if you're predicting the effect of all the X variables simultaneously. So if all those variables were zero, then there would be some y-intercept for oxy, right? And that's the interpretation. The reason it's not really interpretable. So the reason it doesn't really have a interpretation in the multiple variable context is because looking at multiple graphs in like kind of essentially three-dimensional, four-dimensional, because you're looking at more than one thing. So in the single regression context like this, it does have an interpretation because this is how many golf clubs would be consumed with no price. But when you have multiple variables, it doesn't really have an interpretation because you're not looking at everything on one graph. You're looking at a bunch of variables at the same time. So what it means is if all the other x variable betas are zero, that's what, in theory, the oxy level should be. The interpretation of that is not important. Okay, so so here's the, like when you see that the intercept is significant, that doesn't matter. It doesn't matter if it's significant or not. All it means is that, like I said, if betas for age, weight, run type, run pulse, uh, sorry, not the betas, but if value, like if you put in a zero for all these things, that's what the run pulse, that's what the oxy would be 101. It doesn't really have a theoretical interpretation other than you got to have it to set up the model. So there it is. So the important thing is you think runtime and run pulse are going to be significant. I need to check for age and max pulse because they're on the fringe, and weight and rep pulse are going to be thrown out eventually because we couldn't confirm those results. All right. So everything good so far? Did I answer your intercept question? Yeah. Okay, great. Um, all right. So what do we want to do next is I guess I can, in the example, it shows you how to save something to a data table. So to do that, it'll save it to like the spreadsheet in JMP if you want to refer to it later. So you can, so what we can do, because if we have multiple models, the same spreadsheet, which we're going to have here, we tested the big one. Now we're going to test smaller ones because we found out that at least two of the variables are going to be omitted due to no significance. So if you click on the red triangle there under response oxy, and then under save script data table, what I'm doing here, you can save that as Oxy full model. And hit OK. Okay, and so what that'll do is if I close this part, you should see the model right there. And it's like a Oxy full model. And if you click that or double click that, it should bring up the results or the analysis you just did. There we go. So it should save your little model. And that way, if you have multiple models like we're going to have, you can refer to each one individually in the same JMP file. Sure. So repeat the step to save the data table. Okay, so when you're here on the Results tab, click on the red triangle under Response Oxy. And then go to Save Script. And then go to Data Table. And just give your model name. I gave it the name Oxy full model. It's the full model with all the X variables. Right, and then if you hit OK, you should save it in the little like spreadsheet area for JMP where you can open it up at a later time. So okay, now we're gonna look. We're gonna respecify the model, and we're gonna look for outliers. You're welcome. We're gonna look for outliers, and okay. So with the same data tab, the fitness data set in JMP like this. Let's do analyze multivariate methods and multivariate. Okay, analyze multivariate methods, multivariate. Let's put age, runtime, and run pulse in the Y columns. Okay. Age, runtime, and run pulse in the Y columns, and then hit OK. Okay. And if you click on the red triangle, you should get this scatter plot matrix thing. And what this tells you is the plot of each variable against the other ones. Like this is age and runtime. This is runtime and run pulse, and so on. This is age and run pulse. So it kind of tells you the variables against each other in a little scatter plot. If you click on the red triangle next to multivariate, and then you click on, let's do that first. Okay, so red triangle next to multivariate, then outlier analysis. And I can't pronounce this, but Melanobitis, that one. That's the one you want. Okay. So what this is our out is a one outlier analysis option in JMP, and the idea is that all the observations, if they're below the little blue dotted line, then they check okay. If they're above the blue dotted line or on it, then they could potentially be outliers. And if you scroll over, you can see that that potential outlier is William, right? So if we look back at our data set, here's William. Let's see what, okay, so in terms of age, runtime, and run pulse, um, well, unfortunately, it looks like he's low compared to the rest of the sample. So looks like the reason why he might be an outlier is because he ran the model, ran the race or whatever this exercise was the slowest. Right? You know, he's the only 14, so he was like essentially like a minute longer than anyone else. Exactly, yeah. So uh, that's why William is coming up as an outlier because it looks like I mean, maybe he's fast for non-athletes, but in terms of these samples, a little bit out of the range, and so we might want to check him as a potential outlier. Okay, now we can do another test of the outlier analysis, and this is the jackknife one. If you do multivariate outlier, multivariate triangle, outlier analysis, and then jackknife distances. Okay, we can also see uh, in this concept, it's the same kind of test, but a different metric. So anyone over the blue line could be an outlier. Let's see if that's William again. So good chance after doing a couple analyses that William could be an outlier. He doesn't seem like he's skewing the results, but he had enough observations. This case we only have 30, I think. Might want to leave him in, but it's if say we had like over 100 observations, we might consider taking him out if he was a minute slower than all the other participants. But kind of, it's not like it's that far out of it's not like he ran 20 minutes, but he could be an outlier. Okay. Now let's look for. All right. So let's So we want to look at another level of outlier analysis. So I think we want to go back to the regression results. So if you want, you can also save this. If you don't want to do it again, or if you wanted to look at it later, you can save this little test as a separate data table. Okay, so if you click on the top bar where it says the red triangle under multivariate, and save script, and then save data table. Save this as outliers. Okay, and then that analysis or model or evaluation should be available in the regular spreadsheet over here, see? Okay, so then let's go back to the Oxy full model. Just click on the little, if you saved it as a data table, click on the little blue triangle. And then under the response, if you go back here to the full model, under response Oxy, then row diagnostics, and then plot effect leverage. You already have that? Mm. Okay, one second. Let me see what. Oh, we already have this. So we have that. Okay. So we already have the plots, actual by predicted plot, leverage plots. Okay, so we're going to use one of these plots to test again with a different method for outliers. So everyone should be here. We actually didn't do anything except pull up the Oxy full model again to be on this page. You can scroll over like I did to the leverage plot for run pulse. This one here, run pulse leverage plot. Okay. So sorry, I got a little. We already looked at this stuff, but what we're gonna do is do another um, test of outliers. I think we want to click on the response oxy triangle up here. And we go to, this is back on the, like if you go all the way back to the left, under the main response oxy triangle or window, or drop down, save columns, and Cook's D influence. See that? So response oxy drop down, save columns, then Cook's D influence. And what that should do is add a new column to the data table that we can go see. Right there. So it should have made a new column for you. So if you didn't get that, let me know and I can repeat, but it should have created a Cook's D column for you in the main data set, probably right next to run polls. Okay. Then let's go to Analyze menu, then Distribution. And you're going to choose Cook's D influence only and put that in the Y column. All right, so Analyze Distribution and put Cook's D in the Y column, and that's it. Then just hit OK. Okay, so this will tell you different potential outliers based on different significance levels. So let's look at, there's Gracie. There's Harriet. Sammy, and then you didn't get William this time. They were looking at something else. So what we're going to do is specify a specific cutoff for cooks, and then evaluate that for outliers. Okay, so from this, just from the top down, click on rows, and then data filter, like that. And we're gonna select Cook D's influence, and click on the Add button. And we're going to select the minimum cutoff to be 0.129. And before we do that, it explains that on the little printout here. This is what you're following along for the exercise. So the reason why we want to make it a specific number is because this is somewhat of a small sample, and the suggested cutoff for cooks is 4 divided by n. So if there's 31 observations, we're going to divide 4 by 31 and make that cutoff. Right there, so that's why we get the 0.29, because that's 4 divided by the number of observations. So we need to enter that here. Let's see. And see right there, I'm gonna just gonna type in 0.129. Okay, and then we don't need to change the top one. Let's just see if that. Right, so if you make the minimum one right there, 0.129, and hit um, go back to the plot. Looks like this analysis, the potential observations that are outliers are Gracie and Harriet. Okay, so if we got that, let's go see why that might be the case. Well, she has a pretty high oxygen level in general, so that's she has the highest, so that's a possibility. And Harriet, not so sure why she would be an outlier, but the ones I could see could why we got this result was remember the William one. He was so I think the outliers are just this was the slowest person. Um, this was she looks like she had the highest Y value of all the samples, and Donna there too. So actually, it looks like Donna and Gracie both had really high oxy levels compared to the rest. So maybe not the best um, results interpretations, but because they just uh, for whatever reason their oxygen levels were higher than everyone else. So it looks like kind of the it's kind of hard to diagnose with all these variables, but um, people with like really high Y values outside of the sample, and people with one of the variables that's like outside the norm, like William was slower by a minute, could be reasons why the analysis is skewed. But again, it's a pretty small sample, so probably don't need to remove those people. But it is important to use that tool at your disposal and kind of if you think there's something going on, you can use any of those three things, outlier tests, and check for outliers. Right. And then if you want to save the Cook's part or this part we just did as another data table, you can. under data table and then save script to data table. We can call this XD. So then I think for this one, you can just save the whole JMP file because if you did a report, you'd have three separate ones. I did three separate things for this one. So if you want, your full version should have the Oxy full model over there in the data table, the outliers one, and also the cooks you can access. Then you can save the whole file if you're done with it as something like okay. So homework 3 part 1, actually homework 3 part 1 question 1. Something like that. Homework 3.1 Q1 or whatever indicator it is to be homework 3 part 1 and then question 1. And you can save that as a JMP file, not the JRP file, but a full JMP file. And then when I open it up, I should be able to see your three data tables that can pop up there. Right? Okay, and then when you're done with this, this part at least, you can post that under discussions and homework 3. Okay. So we got some more to do to discuss the results, but that's the analysis part for JMP for this one, this question. Everybody good on this? Anybody need any steps repeated? Oh, okay. Sorry, I think I missed some questions here. So, how did I get the plot effect? I think one was already done. I just wasn't. I kind of went backwards. So, the plot effect. If you open up the Oxy model, I think it was just there, right? Or we did it the first time. And then okay, great. And then oh, you want me to repeat the Cook's D influence? I can do that real quick. Right. So let me just do the Cook's D influence part real quick, and then we'll go on to the next thing and do some interpretations or explain the results. Okay, so to do the Cook's D part, first you want to pull up the Oxy full model. Then click the red triangle under Response Oxy and do Save Columns. And then Cook's D Influence, and then that should put the column there for you. Right there. And then you want to do Analyze. Distribution. And you want to put the Cook's D Influence Oxy into the Y column. Hit OK. And then that should bring up this. And then the only thing we did here was change the filter slightly to make it the appropriate cutoff. So if you click on rows and data filter, and then click D Influence Only, hit Add. All right, and all we did was change the bottom threshold to 0.129. Okay, and that should do it. And then that should give you your potential outliers. If you close that, where you should see options for outliers are Gracie and Harriet. All right, and then if you got that, you can save this as another data table. Okay, so we know Hermione if that you got that.
Yes, Professor, thank you.
Okay, you're welcome. And is the cutoff strictly always 4 divided by the number of observations minimum? That's the rule of thumb. Especially, you can just leave it as the normal one it sets you, but the reason why we changed is because we have a very small number of observations, so the default might be wrong, or not might be wrong, but we need to make sure that it's set to the right number. So there's like a default that already had it for cooks you can just go with. But because it's the suggested rule is 4 divided by n, especially if you have a small number of observations like 30. So yeah, but there's also a default option if you want to go with that. But you have the option of changing it if you want. In this case, we changed it to 4 divided by n. Okay, so again, this one you got the Oxy full model, you got the outliers with the 2 outlier analyses, and then the Cook's D. And you save this one as a JMP file. and you can post that part now or when you're done with it into the discussions. Okay, so let me run you through the interpretation part of this one. Okay, so what you want to write in your report, you do your Word document of the interpretations of what you just did. So it's kind of similar to what we did last time, the models, but here you want to write the full model out with the coefficients. So there it is. But I think it probably gives it to you. You can just kind of go with a JMP report here. Or maybe it doesn't give it to you, but these are the coefficients here. So your model you would put in your report with the full coefficients would be oxy equals the intercept plus that, or I guess minus 0.21 times age minus 0.07 times weight minus 2.64 times runtime minus 3.7 times run pulse minus 0.02 times run pulse and then plus 0.30 times max pulse. Most of the variables reduce your oxygen level because it's they have a negative effect or a negative relationship, right? And then that full equation would look something like this. Okay, so whatever I just told you is something like this, and here's the full effect with most of the negative coefficients. And so you write the full model out basically with the coefficient or with the y variable oxy equals some intercept, and then with all the estimated coefficients that you got from JMP times the variable. So then I know that if age were to go up by 1, I would expect this was significant, which is not, but I would expect that the oxy level will go down by 0.2. Okay, so there's your full model, something like that. Put that in your report. Okay, so we can also interpret the F ratio, which we went through. 18.7, is that what we got? Looks like we got 22. So maybe one is really high enough, but looks like our F ratio, or at least I think the one I got just now was 22.2. All right, you can throw that in your report. And you know that that's high enough to be significant. So the F statistic is whatever you got. I think it's 22. is high enough and significant at the 99% level, so that's confirmed. And then the p-value for f right there is less than 0.001. It's yellow, it's highlighted. Orange, sorry, and that means it's significant at the 99% level as well. Okay, and then remember we got that oh yeah, so we maybe I did forget that, huh? Oh yeah, whoops. We were supposed to include um I know this I've done this before, but it doesn't come out significant. But we were supposed to use gender as a binary variable, which I forgot. Um, so let me just do it. But you can either you don't have to redo the analysis if you've already done it. So your choice. You can either go with what you got and interpret it, or you can redo it with putting gender in there. You don't have to change anything else. I just want to show you what the result would be. So if you wanted to do the analysis, and include gender as a binary variable, which I forgot. You would do analyze and fit model. Then you would do oxy is the y variable. I missed it because it was like categorized differently. You can see that the other ones are like blue as numbers, and then so you can don't put name because that won't do anything. You can put gender into the struct model effects. You can also put the ones we had before if you want to do it again. Age, weight, runtime, run pulse, rest pulse, and max pulse. Okay, so same model, but now with gender also as an option. So pretty similar results. Yeah, that's why the F ratio was 18, which it would be if you included it. Actually, it made it worse because it was a bad variable. So gender as a category wasn't significant. So male or female in this sample didn't have an effect on your outcome. Same variables were significant at the 99% level. And it actually looks like lost one because it might have got mixed in the lost in the translation of what's going on with gender. See, also important, even though it's not significant, it says gender F. So it made a specific category for female, and then if the individual was not female, it would be 0, and that would be the other case. But no effect for gender. And you can see that there. You can see the two that were 99% significant are still significant. Same with this one, but we also, what was the one that was, anyway. Yeah, so let's save this one as another option. All right. So to interpret it, I guess we have options now, but if you want to put this in here, you can. The only categorical variable or binary variable, gender female, wasn't significant. So we couldn't confirm that the average oxy is different based on just being male or female. So we can put that caveat. And if you did the second model, the parameter estimates for age, weight, rest pulse, not significant. So no relationship there. Okay, see? And if you look at, if you want to just go with the one we did the first time, you could say, if you want to interpret this one, you could say that weight, the run pulse were not significant. Run time and run pulse were significant at the 99% level, and age and max pulse were significant at the 95% level. So whichever one you're going with, just interpret it as such. And then what you want to do is if you want to interpret the results from the significant variables only, you can do that, or you should do that. So this one is based on the updated one with the gender, which wasn't significant, but okay. So here's the gender one. The significant variables, including the coefficient, are negative 2.6 for run time, negative 0.36 for run pulse, and 0.30 for max pulse. Okay, so what those mean is you're just interpreting that as a 1 unit change in the x variable, and then the corresponding effect on oxy. So if your runtime increases by 1, then your average oxy falls by 2.6, 99% significant. Okay, for run pulse increases by 1, then your average oxy falls by 0.4, 99% significant. And max pulse increases by 1, your average oxy increases by 0.3, and this is 95% significant. Again, you can do this one, or you can stick with the original one. Okay, so if you're doing this one, interpret age goes up by 1, then that's the effect on oxy, 25%. If runtime goes up by 1, then oxy goes down by 2.6, 99%. If run pulse goes up by 1, then oxy goes down by 0.37, 99%. And max pulse goes up by 1. Oxy goes up by 0.3, 25%. Okay, actually, we supposed to. I wanted to show you a reduced model as well. I guess I didn't. Wasn't in the wasn't in the documents, the homework steps, but I added it last time. So let me just show you what I mean. This it's pretty simple, but what you want to do in theory is that go through the analysis, and then if you find variables are not significant, uh, take them out, and then run the model again with the significant variables only. Okay. So if we were to do the model the first time like we did, like this, right? Then we would run the model again and throw out weight and throw out rest pulse because those ones were not significant, and the others were, and see if we got a better model. So we probably will because um, omitting insignificant variables usually has a good effect on the model. So why don't we try that one more time? So if you want to, if you already saved this as a JMP file, you can just open it up again. Um, Let me write down one. So we're gonna take out weight and we're gonna take out rest pulse. So I might do this. Let me put that. Remove weight, rest pulse. So everyone can see what I'm talking about. Where on the original model, those two didn't have a high enough t level or p value. So now we're gonna take them out and run the model again and just look at our results. Okay, so analyze fit model. Okay, so oxy is the y variable. Okay, and also no age, no gender. Um, so we remove weight and rest pulse and gender. This leaves us with uh, age, runtime, impulse, max pulse. Age, runtime, impulse, and max pulse. Okay, so let's rerun model with all the significant variables only. Okay, so the adjusted R squared goes up a little bit. So the F ratio goes up a little bit. So that's a kind of an indicator of a little better model.
Sorry to interrupt you.
Yes.
In this case, the age is not significant. So should we add it or should we not add it? Because the three parameters which include only run time, run pulse, and max pulse, the three variables are significant in this equation. So is the adding age will not affect the overall equation of the basically analysis?
So why do we? So age was not significant in the one of them, right? But there was the other. So you're going with the original one with gender. Right? Yeah. So you only had runtime, run pulse, and max pulse, right? So you could run it with just those three. But I was going with the one we found the first time, where four of the variables were significant. And so
Okay,
either
okay,
way,
Professor, got it. Yes, I got it. Because I think the first equation age was the affecting variable.
the first equation was what?
Yes. Oh, got it, Professor. Got it.
You're welcome. Okay, and then either way, you get a result where I think you'll get down to a case where runtime, run pulse, and max pulse. It's not the root. Hold on. Okay, here we go. Sorry, I think this is it. I have so many windows open. So here's the one with just age, runtime, run pulse, and max pulse. And the conclusion is that runtime and run pulse were significant once you adjusted. So what you can do, and again, you don't have to do all these steps, but I'm just showing you the process of cutting back the model. Is I would instead now look. There's only two significant variables. So let's run the model again, and I bet you that our R squared and our F stat goes up. And I bet you that these two variables continue to be significant because they have been so the whole time at the 99% level. So I can run the model one more time, which is runtime and run pulse. Let me close a few the screen windows here. Okay, so one more attempt. Get a best model, analyze fit model. So we'll use just this time and run pulse, right? Because those ones have been the best ones the whole time. And now we just get one. Okay, so oh, it looks like runtime is the best one again, or only, and our F ratio went up. the r squared, actually the r squared went down a little bit. So I think we'd want to go, so you're looking at a number of different things to pick the best model. And because we're looking at the the main goal here is to predict the effect on oxy. And because of that, we're looking at really the best um, adjusted R square and interpretation of the coefficients. So adjusted R square went down quite a bit, dropping a couple of those variables. So I think I want to go back to the other one and have the other variable in there, even though it wasn't significant because it had some explanatory part the first time. So look at the one we just did. Okay, so here we go again. We had the original, adjust R squared of about 0.81.
Sorry, Professor.
Yeah,
What did
yeah,
you-
yeah, yeah.
Basically, right now, what we are doing is we are finding the highest R square adjust value that we get a best fit equation. Are we doing that right now? Selecting all the variables.
Well, yeah, because it depends what your research goal is. So if you're interested in finding all the things that influence oxy, you might want to do a different approach and include more variables or less. If we just want to explain oxy, then we want to find the best R squared. But if you're interested in looking at, let's say you want to know, your goal is to find all the variables that properly explain oxy instead of oxy itself, and you would want to include more variables and not worry so much about the R squared, just the best variables.
Okay.
But if you just want to explain oxy, which I think this model wants to do, then you want to go with the one with the best R squared.
So basically, if I'm not wrong, so initially what we did was we, as a whole regression, multiple regression, we found out that the three value, which is runtime, run pulse, and the max pulse, are the significant. And then we are playing with the variables to find the best R adjusted value.
Yeah,
That we get the best fit.
that's correct.
Okay, thank you, Professor.
Yeah. All right, so original one, 0.81. Not the same. Also about the same. And then when I did the really reduced one, cut down the R squared a little bit, actually quite a bit. So I think I would go, because this one has the lowest R squared by far, I wouldn't go with this one. And because oxy full model with gender, and then the oxy reduced model one that had the four variables, all had about the same R squared, like 0.81. I think I'd go with the one that had the reduced variables, not the reduced R squared, which would be this one. Okay, so the one that has age, runtime, run pulse, and max pulse seems to have two good variables and two variables that are on the fringe. They're like right on. It's either like right on the fringe, they're 2, but because we have low observations, they're cut off. That's pretty close. Look at the t-values of 2, 8.9, and 2.02. I think those are all justified to be in the model. So this is the one, after doing the analysis, I think I'd go with. I reduced it, but not all the way, because I think these 4 variables are all important. Explaining oxy, even though some are this significant, this is the one I think I'd go with if I was to like report the final results.
So which reduced one is this? The reduced model 1 or 2?
Yeah. So this is the one with oxy as a function of age, runtime, run pulse, max pulse. Those for 4 variables, and the R² is like 0.82, and the F values proved them from the first time, which is 32 or 33 as opposed to 18 or something. Right. So for this example, we did a bunch of things. You can pick whatever model you want to talk about. This one, in theory, would be the best one. But if you have just the first one that we did, you can talk about that one too, as long as you interpret it correctly. But if you were to do the full analysis, I think this is the one you'd want to end up with. Okay, so does that make sense? What I like, kind of like steps to get to the best? Yeah. Okay. Okay, and then the part we did earlier but didn't talk about were the outliers. So we checked for outliers in 2 methods. This I can't pronounce, and the jackknife, and we found outlier possibilities of. Actually, we only found William because we didn't include the gender variable, but so you can just say that we found William as a possibility for the first test. And then we did the Cooks-T-Oxy, and we found that Gracie, because we found Gracie and Donna. I don't know if we found Donna, but you can see why it would be Donna and Gracie, because they have really high oxy levels compared to the others. Potential outliers as well. Right. So if you want, or not if you want, but include just a couple of sentences on the outlier analysis, what you did, who you found as outliers, and at least include William as a potential outlier because he was slow, and Donna and or Gracie because they were, and the reason they were there is because they had really high oxy levels in relative to the rest of the population or sample. So that is the full report for question 1, or assignment 3, part 1, question 1. Sorry. So you would write out the full model. Again, you just pick one of the ones. You can either include the full model or the reduced model, whichever one you want to talk about here. I mentioned the R ratio and what that means, p-value, the whole model. I mentioned which variables were not significant, and the variables that were significant, talk about what those interpretations mean and what level they're significant at. And then if you did a reduced form, can write that one. Not, it's not required because we kind of did that at the end. And definitely interpret the outlier analysis. And you will basically do the same kind of little report for the other two questions. But this is the idea for the multiple regression homework.
Professor Hoffman, for the other questions, do we also have to do like a reduced model?
In theory, you do, but because I already know the results, no, because I picked models that are not going to need to be reduced. So no, but you would if you weren't sure. Like next one. Is a cost the cost regression 2 Excel file. Okay, so this one here, and remember, for the Excel files, you can either drag the file into JMP, or you can open it up from JMP, whatever worked last time. But this one is going to have let me just I'll pull this one up so you can see it.
Okay, thank you.
So remember, you can just open it up the way you did last time, or I just like to drag it in there. And hit import. So this one, you have a cost regression 2 file. And for some hypothetical firm, you're going to estimate the effect on total cost of producing 3 different types of products. So how much does it cost on average, holding other things constant, to produce 1 unit of product A, product B, and product C, because there's 3 specific products for this firm. So you would estimate the form of where total cost is the Y variable, and it's A, B, and C, the X variables, and interpret your results as such. And because you know that this one is not, all the variables are going to be significant, you're not going to need to reduce it, so you don't have to worry about that. But I can actually, you want to do this one, we can just run the analysis real quick and I'll show you the kind of the same steps. You want to do this one to see a similar, kind of repeat the analysis with a different data set. You can open up the cost regression 2 Excel file that's posted on Blackboard and get it open in JMP like you did last time with the other Excel files. And we got 15 months of observations for total cost and then 3 specific products. Okay, so you would just do analyze fit model. The total cost is the Y variable. Then units A, B, and C are the X variables. And you would hit run. Okay, so this is the regression results, and you can see that all the variables are significant, so you don't have to worry about reducing it. All you have to do next, first you want to save this part. Is everybody good so far if you're trying to do this part? Great. Okay, so why don't we save this one as I don't know, some kind of model. So save it as a data table. Uh, response save script to data table. Okay, and call it the TC for total cost model. So then you want to do it for the outlier test. So you can do uh, analyze. Multivariate methods, and then multivariate, like we did last time. And then you're going to add everything except the dependent variable over there. You're gonna add units A, units B, and units C. To the Y columns. All right, because they're all significant, and you want to include all the X variables. And hit OK. Okay, then click on the red triangle next, or the drop down next to multivariate. Then outlier analysis. And then this one. So you can see that there's no outliers here because they're all below the threshold. So no outliers, you can say that in your report. And then if you did it for the other one, the jackknife. Okay, no outliers again. So those two checks didn't give any outliers. You can save this. Okay, and then let's just do the Cook's D for this one, so you can get the full model or the full steps for a second example. So you can open up the total cost model. Then click on the red triangle next to response total cost. and then save columns, Cook's D influence. Okay, and you should see those there, right? And they are. Then just look at the for outliers to do analyze distribution. And then add Cook's D over there and hit OK. So might have one, but then we can do the adjustment if you want. So there's 15 observations. So 4 divided by 15. That's about 0.27. So that can be our cutoff. On the Cook's D window, sure.
Wasn't the right next to
Yes, there it is.
distribution?
Sorry, I couldn't find it's
Oh.
Rose data filter. Yeah, thank you. So on the Cook's D, go down to Rose, then data filter. Okay, and we can hit Cook's D and then the add button. And we can specify 0.27-ish, 0.27. So row 3, not sure what that would be an outlier, but let's. Yeah, so that, I don't know, that's what it's, that says row 3 is a potential outlier, but I'm not able to, wouldn't take it out based on that finding, but looks, I mean, there's the units A's small, relatively, but everything else seems relatively in the same range. So my only thought would be that they produced, yeah, that this month they produce a lot less of product A. You see that relatively, so that actually that could be it. For some reason, that month led to a much smaller production of units A, so it could be something unusual happened, like there was a production constraint, like hiccup or I don't know, some reason they couldn't produce enough of that product, but I guess you can make a note that possibly, although I wouldn't take it out, units A in month 3 were a little bit weird, and that's the result of the findings. Okay. So just to show you how to repeat the analysis, again for problems 2 and 3, in theory you would have to check for um, options to reduce the model, but I'm just telling you that you're not going to have to reduce it because we know that all the variables are significant. Write out the full model with the coefficients that you got from the report. Okay. Then write out the F ratio, and that's going to tell you it's significant at 99%. Same with the p-value. Everything's going to be significant. Just interpret the coefficients here as average cost to produce each specific unit type of product. So if you got units A had a coefficient of 12.80, it would tell you that it costs about $12.80 to produce 1 unit of product A on average. So if basically you're like interpreting into if 1 unit goes up, how that it be interpreted in like a business cost. So if unit goes up by 1 and the cost goes up by that, then that's obviously the average cost per unit. So each of these would be cost whatever the coefficient is in dollars to produce 1 unit of that product on average. Okay. And then tell the report that you did the jackknife and the other one, and you didn't find any outliers, and you did the Cook's D. You found row 3. If you saw row 8, if you saw a potential outlier, you can say that row 3 because the units in month 3 for product A were super low. Okay. So each of your okay, so this homework should have one big Excel file or printout or write out the results interpreted from all the models or examples, and three separate MP files. Each one should have a data table for at least one of the regression models, and then the outlier test, and then I guess I forgot to save the D here, but also the Cook's D. Okay, so each JMP file per question would have the model, a data table for the model, and then a data table for each of the outlier tests, Cook's D and the other one. And then should be able to do this one. Okay, so for the third one, you're going to use cost regression 3. And for this firm, I'll just tell you what you're doing. You're going to look at the effect on total cost of producing 1 unit of a product. And there's going to be various plants. So there's going to be production of different plants. And that's an example of binary variables or categories. How much does it cost on average? All the other things constant to produce 1 unit. And then also, does the cost vary at different plants? So you'd interpret it the same way, but see how when you write out the equation, you have the intercept, um, coefficient, and the variable for units produced. It's only going to have, only going to do, you know what, this one's a little, I just want to check the Excel file to see if I. Yeah. We this one's a little bit different because you have to interpret it differently and you have to set it up a little bit differently because I wanted to show you the use of binary variables. So we cover this one next week because I don't want to already been gone straight here for over 2.5 hours. I don't want to. If we go farther, we'll probably have to take a break. So I think we might as well just wrap it up and cover this one next time. So you can try to play around with this one, but we'll cover it next week. This homework's not due for a while. In fact, September 23rd. So we'll probably next week cover that last because it's a bit different. I want to explain it properly. I want to cover that last problem for part two. Sorry, for part one. And then we'll also cover part two and see where that gets us. But you should be able to do the first two questions fully and understand them and get that part done. If you want to try to do the third one, you can try that. But if you want to just wait, I'll go through the main concepts next time because it's a bit different with binary variables and it's the interpretation is slightly different. So why don't we wrap it up here? Or any questions before we close up and. All right. So, okay, excellent. I think that is more than enough we can cover for today. We're still a bit ahead. So let's wrap it up here in a minute, but I want to thank you all for flexible and pretty much most of the class came to the meeting, which was great. And I think it was welcome. So I think it was effective and I hope it was still able even though we weren't in person, but I think that was effective, and I want to thank you all for coming and participating and staying here the whole time. So that was great. And I will see everybody back in the classroom next Saturday, and we'll pick up there. But just make sure if you have number one thing is make sure JMP works and you have a working computer with JMP. Get the welcome kit in as soon as possible, and then probably the the other homework. Homework 2 should be getting close to done at some point, and then we'll pick up on this homework and these things next week. But I won't. I'm just going to give everyone full attendance just in case there was some technical issues or somebody left early. So it was a bit of a change of attendance or a change of classroom. So everyone gets full attendance for today, and I will. We're recording the meeting, so I'm going to let it finish processing. Then I'll post it up on my YouTube channel and give you all a link to it in case you missed something or if one of your classmates couldn't attend, they can watch it there. But I think that'll get us a good set there. And yeah, thanks again. Have a great 3-day weekend, and I'll see everyone back in the normal classroom next Saturday. And thanks again.
I have a question.
Thank you.
You can hear me?
Yeah.
Going back on the Cook D on the first one we did.
Yes.
Mine looks different than the one that's posted on the homework 2 where we could follow along. It's doesn't look like the one on the image shown here.
Does it look like the one we did together, or does it not look like the one on the printout?
It doesn't look like the one on the printout. It looks different.
I think that's okay because mine did too. So as long as you got, I mean, there's sometimes it might have changed one of the letters or something, or I'm not sure, or it might have been with different variables because we didn't do the gender one the first time, so that could have messed it up or made it slightly different. So just whatever you got the result, just go with that interpretation, and as long as you know how to interpret it and use the metric, then the results are fine.
All right, cool. Thank you.
Yep, you're welcome.
All right. Thank you, Professor. Have a good weekend.
Yeah, thank you.
I just have a quick sidebar. That's my probably
Yeah,
my
no,
computer's problem.
sure.
When I try to do and follow along with your cost regression, and after I download it and import it into JMP, it doesn't carry over all the way. Like there's no column headers. Half the data is like in the top column, so really it's only showing 13 variables instead of 15.
When you import the Excel file?
Yeah, so I couldn't follow along with the whole with the end part there because all the data was messed up. There's only 13 instead of 15. The top.
Yeah, I think you just need to re-import it, and then when you're importing it, change the row thing again to be the correct number. Like the column header starts in row 1, or data starts in row 2, or something like that. So there should be some quick adjustments you can make when you import the file, like before you hit import.
Okay.
And then if that doesn't work, let me know, and I can try to help you with it. But I think we did that last week, and so see.
Oh, okay. I see what you're saying. I think it messed it up when I was practicing before this session.
Okay.
Yeah, I see what you're saying. I just don't know what the change is, but I'll mess around with it.
Okay.
Adam, in my case, I just try to restore default setting before I import the.
Okay. I see what you're saying. Restore default. That's exactly what I need.
You can use that button, the right bottom. Right
100%. That already fixed it. Thank you so much, whoever said that.
Yeah. Oh, great. Okay. Good.
Perfect. All right. Thank you.
You're welcome.
Have a good weekend.
You too.